Hey guys, so we're moving on to solving a system of linear equation using what is known as the substitution method. So when you're solving a system of two equations, meaning that you have two y equals mx plus b equations, right? What you're really doing, or what you're essentially doing, is you're finding the x value and the y value that work for both equations in the system. So you're figuring out what's x equal to, what's y equal to, that works for both of the equations. So in order to do this through the substitution method, first thing you're going to do is isolate one of the variables. So basically make sure that one of the variables is by itself. And then what you're going to do is you're going to substitute that variable into the other equation. And then you're going to solve for the variable in the new equation. And then substitute your answer into either equation to find the other variable. It sounds like a lot of steps and a lot of words, but you have to watch it worked out in order to truly understand how it works. So watch how we do the first one. So solve the system of equations using the substitution method. So here's what we're going to do. Both equations are actually y equals. That means both equations are already in the form y equals mx plus b, and the y is by itself. Okay, so one of our variables is already by itself, so we don't have to do any work there. So watch what I'm going to do. What I'm going to do is I'm going to take this y equals 5x plus 9, and I'm going to plug it in for the y in the first equation. So it's going to look something like this. 5x plus 9 is equal to 8x minus 6. So all I did was I took the y and I plugged the y in my second equation and I plugged it in for the y in my first equation. Now I'm going to use this equation to solve for x since they both have the same variable. So to solve for x here, I'm going to get my x's on one side and my numbers on the other. So first thing I'm going to do is I'm going to subtract the 5x to move it over here. And when I do that, I'm left with 9 equals 3x minus 6, and then I'm going to add the 6 onto the other side so that my numbers are on the other side, and I'm left with 15 is equal to 3x, divide by 3, x is 5. So we have one of our answers, x is 5. Now in order to get our final solution, we need to figure out what y is. So this x equals 5 can plug into either of the first two equations. So either one of these two equations it could go in for. In this case, I'm going to plug it back in to the first equation just because it's the one that's the first one there. So I'm going to plug that x equals 5 in for the x in the first equation, and I'm going to do my workout over here. So I have y equals 8 times 5 minus 6, and 8 times 5 is 40, minus 6 is 34. So my two answers are 5 for x and y is 34. Sometimes they ask us to write our answers in an ordered pair. So when you write your answer, make sure you say 5, comma, 34. And that's our final answer. Okay? So substitution only works if one of the variables is already by itself. So let's try the next equation using substitution. Notice that both equations already have a variable y by itself. So what I'm going to do is I'm going to take this second equation, y equals 3x minus 7, and I'm going to plug it in for the y in the first equation. So I'm going to take that entire thing, this 3x minus 7, and I'm going to plug it in to that equation. So that when I do so, I have 3x minus 7 over here equals negative x plus 5. And then I'm going to solve. So get my x's onto one side. So I'm going to add the x first onto one side. And that's going to get me 4x minus 7 is equal to 5. And then I'm going to add the 7, so I got my numbers on the other side. And I get 4x is equal to 12. Then I'm going to divide by 4 on both sides. And I get a final answer of x is 3. Now that I found one of my variables, I'm going to take it and plug it into either equation, does not matter which. In this case, I'm just going to plug it in for that top equation again. So when I do so, I get y equals negative 3 plus 5. And negative 3 plus 5 is 2. So y is equal to 2. So our final answer is 3, 2 as a solution to this system of equations. Let's look at a couple more examples so that you guys can get the hang of the substitution method. In example number 1, notice that the first equation is already set up where one variable is by itself, and that happens to be the x. So in the first equation, it says x is 2y minus 5. So what I'm going to do is I'm going to plug that in, that 2y minus 5, in for my x value in the second equation. Watch what it looks like. So you have 2 times 2y minus 5, okay, minus 3y is equal to negative 6. And this is where it gets a little bit trickier, and you have to recall how to solve equations like what you did back in multi-step equations, like back in Algebra 1. So first I'm going to get rid of the parentheses. I'm going to take this 2 and multiply it into both pieces. So I have 4y minus 10 minus 3y is equal to negative 6. Then I'm going to combine like terms. Notice that I have a 4y minus a 3y. So 4 minus 3 is just y. Minus 10 is equal to negative 6. I'm going to add the 10 onto both sides, and I'm left with y equals 4. So we've got the y. So again, you can plug it back into any equation. But in this case, what I would do is I would plug that y back into the first equation. That way you can find out what the x is right off the back. So when I do that, I get x equals 2 times 4 minus 5. 2 times 4 is 8 minus 5. So x is 3. So our final answer here is going to be 3, comma, 4. The ordered pair 3, 4 is our solution to this system of equations. So notice you are also going to need quite a bit of room when you are doing this. Now in the next one, we don't have either equation equal to where what the variable is by itself. But if you look at this first equation, you can easily make that into, get the y by itself there, simply by adding the 2x onto both sides. So when I do that, I'm going to get my y by itself, and it's going to be y equals 4 plus 2x. Now that I have a y by itself, or a variable by itself, I'm going to plug it in to my other equation. So 4 plus 2x, I'm going to plug in for my y in my second equation. Let's watch what it looks like. So I have negative 5x plus 2, open up parentheses. I'm replacing the y with 4 plus 2x is equal to 9. Okay? So see how the y got replaced with this 4 plus 2x. Now we're going to distribute, just like we did in the last one. So you've got negative 5x plus 2 times 4 is 8, plus 2 times 2 is 4x, which is equal to 9. Then you're going to combine like terms. Look at your like terms here. You've got negative 5x and 4x. So negative 5 plus 4 is negative 1x, if you want to call it that, plus 8 is equal to 9. Minus 8 from both sides. Negative 1x is equal to 1. Divide the negative 1 from both sides. So x is really negative 1. There's your value of one of them. Now in order to find the other, in order to find the y, I'm going to take this x value and plug it back into one of the equations. And I think I'm going to actually plug it into my first equation right there. Okay? So when I do so, I get y equals 4 plus 2 times negative 1. And 2 times negative 1 is negative 2. So you got 4 plus negative 2, which is 2. So our final answer for the solution to this system of equations would be written as an ordered pair where x is negative 1 and y is 2. Okay, there's our final answer there. All right, let's try a couple more just to get our practice in, and make sure that you're writing small on these because you need all the room you can get. So in this equation, notice again that one of the variables is already by itself, the y is already by itself, and it's equal to x minus 1. So I'm going to take that and I'm going to plug it in to the top equation. So I'm going to get 2x minus 3, open up parentheses, replacing y with x minus 1 is equal to negative 1. Okay, so I replace that y. Now we're going to distribute, just like we did before. 2x minus 3 times x is 3x, and 3 times negative 1, or negative 3 times negative 1, is positive 3. That's how I would write that one, equal to negative 1. Okay, then I'm going to combine like terms. I've got 2 minus 3x here, which is negative 1x again, plus 3 is equal to negative 1, minus 3 from both sides. Negative 1x is equal to negative 4. Divide the negative 1 out. X is equal to 4 there. Okay. Now that you got one answer, you plug it back in. So I'm going to take that x equal to 4, and I'm going to plug it back into my second equation this time because I think that will be easier to find the y. So when I do so, I get y equals 4 minus 1, which is 3. So our final answer to this system of equations is 4, 3 as a solution. Okay. Number 4, you're going to need a little bit of room because we have to solve for one of the variables first. And if you look at both of the equations, the one that's easier to solve for one of the variables would definitely be this second equation right here because the x is almost by itself. There's just one thing you have to do, and you got to get rid of the 2y. So to get rid of the 2y or move it on the other side, I'm going to add it. And then I get an equation of x equals 11 plus 2y. Now that I have one of the variables by itself, I'm going to take that x value of 11 plus 2y, and I'm going to plug it in for my x value in the top. So this is going to take quite the bit of work if we're plugging this in, and we got to distribute. So watch how we write it. We put negative 7, parentheses, replace that x with 11 plus 2y, close parentheses, minus 2y is equal to negative 13. Okay, so there's that x that we replaced right there, 11 plus 2y. Now we're going to distribute. So we're going to take that negative 7, we're going to multiply it into both pieces. So negative 7 times 11 is negative 77. Negative 7 times 2y is negative 14y. Minus 2y is equal to negative 13. And then negative 14 minus 2y, we're going to combine like terms here. So we've got the like terms, negative 14 minus 2y. That is negative 16. So we've got negative 77 minus 16y is equal to negative 13. Then what we're going to do is we're going to add the 77 onto both sides to get rid of it. And you get negative 16y is equal to 77 minus 13, which is 64. Divide both sides by negative 16, and you get negative 4. So my y value is negative 4. Now I'm going to take that y value and plug it back in so I can find my x. And what I would do is I would take this negative 4 and I would plug it into the second equation because x is already by itself, so that will make it easier to solve. So when I do that, I should get, I'm going to work over here, x equals 11 plus 2 times negative 4. 2 times negative 4 is negative 8, so it's 11 plus negative 8, which is 3. So x is 3. So our final answer for the solution to this system of equations is 3, negative 4. That's how we would write our final answer there. Okay? So notice that this does take quite a bit of scratch work to do and quite a bit of writing down. So make sure you're writing everything down because the smallest little mistake could make something wrong. All right, so let me know if you have any questions as always, and good luck.